Yeah, I want to explain about this I2C master write only. So how to write the code from the master to slave. Here, so this is the code for generating writing from master to slave. So you need to declare the inputs that is clock. This is system clock. Reset underscore n start and address is 7 bit, 6 down to 0. So this is the address and data is 8 bit, 7 down to 0 data. And you need to initialize this output as SCL, that is output serial clock line as output. Okay, and in out, so as this data line is bidirectional, so you need to consider in out, that is a serial data line, and one more signal that is busy. Okay, output range busy. So you need to initialize the states. State is 4 bit, so range 3 down to 0 state, range 3 down to 0 bit control, and one more range HDA out and HDA output enable. Okay, and suppose if HDA equal to HDA enable, then HDA out is assigned to HDA. Okay, or otherwise it will be in the high impedance state. Okay, this is the by using continuous assignment statement. And you need to declare the local parameter that is ideal for 0, start for 1, address for 2, acknowledgement 1 for 3. For write operation, you have 2 acknowledgement. So first, whether the slave is ready or not, master will send the acknowledgement. And after that, after sending 8 bits of data, so one more acknowledgement is sending that 8 bits of data is received or not. Okay, so data equal to 4 and acknowledgement 2 is 5 and stop. So first you need to consider, that means you need to check for, you need to initialize the output of all to initial state. I'm using asynchronous active low reset, that is always at the rate passage of clock or negate of reset begin. If not of reset, that means reset equal to 0 begin. State is idle and SCL is a 1 tick binary 1 and HDA out is 1 tick binary 1 and HDA output enable is 1 tick binary 1 and the busy flag is 1 tick binary 0 and bit control is that is 0 else begin. So now I'm using case statement, that is case state. So when the I2C is in the idle mode, SCL is said to be in 1 and HDA output should be 1 and it should be busy flag, that is busy equal to 0. So if start begin, busy flag becomes 1 and it is go to the next state, that is start. Okay, in the start, first during the start condition, HDA will go from high to low. After that, SCL will go from high to low. So first HDA is going. So this is the start condition. HDA out is going to 0. And next you need to find out the slave address, that is 7 bit and bit control is 7 bit and address address. Okay, begin SCL is 1 tick binary 0 and whatever the bit control address is there, that is coming to HDA out and SCL you are making as 1. After making HDA out 0, I need to make this as 1 and this is for acknowledgement. State equal to ACK1, whether like it should identify the slave. Okay, so whether the slave is ready or not. Okay, HDA out is 1 tick binary 0. This is for there is two operations are there, read by write bar signal. So when read by write bar equal to 0, so master can write the data into the slave, and when read by write bar equal to 1, master can read the data from the slave. So this is write operation. That's why I need to make HDA out equal to 1 tick binary 0 and bit control I'm decrementing by 1 and this is acknowledgement. So during the acknowledgement I should make SCL to 0, HDA output enable, so to 0 to release HDA for acknowledgement and SCL to 1 and state is data, bit control count is 7 and HDA output enable is 1 tick binary 1. And coming to the data, SCL is a 1 tick binary 0 and whatever the data that is 8 bit of data is there, that is coming into the HDA out and SCL equal to 1 tick binary 1 and if bit count equal to 0, then next after sending 8 bit of data, again it should send the acknowledgement, no? So state equal to acknowledgement 2 and you are decrementing every time the number of states are happening, the bit control is decrementing, no? So you are going into ACK2 So in the ACK to SCL, you need to make it to 0, and HDA output enable, you need to make it to 0 to release HDA for acknowledgement, and SCL to 1. Okay, acknowledgement will be coming when you need to make SCL to 1. Okay, and next state is stop condition, and HDA output enable equal to 1. And in the stop condition, initially when the I2C is doing transmission or during the start condition, SCL will go to low. No? After first in the stop condition, first you need to make SCL to from low to high, and HDA is 0 and HDA output is one tick binary 1. So HDA output you are making a 0 to 1, that is stop condition. And again, after stop condition, it will go to the idle state. During the idle state, it will be that means busy flag will be 0. Okay, so this is about total I2C program. And coming to the test bench, so whatever the input variables are there, that I need to declare with rich data type. What are the inputs? Clock reset underscore n start 6 down to 0 address. This is the address of the slave, and 7 down to 0 data, and a serial clock line and serial data line and busy flag. These are the outputs I need to declare with y data type. And pull up resistor, I need to make this as a like a function pull up HDA, and I'm instantiating connection by name. This is connection by name. So whatever the outputs are there, those outputs are outside the bracket are nothing but design inputs and outputs, and inside the bracket are nothing but test bench inputs and outputs. And you need to generate the clock. Okay, clock equal to 0 forever. Hash 5 clock equal to not of clock. You are generating 100 megahertz of clock, and initial begin. First I'm applying the reset. Okay, reset underscore in equal to 0. So start equal to 0, and this is the address and this is the data. After 25 minutes, I'm deassetting the reset. Reset underscore n equal to 1, and after 35 minutes, I'm start that is equal to 1, trigger the transaction, and after 10 minutes, I'm making the start equal to 0, and I'm running for 500 time minutes. Okay, so this I want to execute. This I wrote the code and in the Linux Vivado. Okay, so whatever I'm simulating, you need to set as stop, set as stop. So run simulation, run behavioral simulation. So here you can see the waveform. So this is the waveform like during busy condition only. So this is the start condition. When start condition is there, and this is the address of the slave, and this is the A42 is the address of the slave, and A5 is the data need to write into the slave. Okay, and next HDA. HDA is when it is a start condition, it should go from high to low. Okay, this is it should go from high to low during after start condition. It should go from high to low. Okay, and during ACK that should go to high, and all those things during the busy condition only. That whatever the data is there, the data will be loaded. And this is a asynchronous active low reset. So first reset is applied. After that reset will be deasserted, and this is my clock. Okay, this is the waveform. Okay, hope you understood. Next is read operation. Okay, this is the test bench. I2C read operation. So in the read operation, what happens means that there is only one acknowledgement signal. Master should read the data present in the slave. Okay. So here same thing. So simple I2C master read. Okay. It generates the start, send the 7 bit of address, and read bit. Read by write bar should be equal to 1. Okay. And it receives a 1 data byte, that is 8 bit of data from the slave, and then stop. Okay. This is my sequence. First, you need to declare the inputs and outputs. System clock is input, and reset underscore in is also active or reset. Start, and address of the slave, that is 6 down to 0, that is 7 bit, and output is SCL. Okay, output, this is master is generating the clock, so that's why this is output. And data is bidirectional. Okay, data can come from slave to master or go from master to slave. During the write operation, master data is sending from master to slave. During the read operation, data is coming from the slave to master. So that is bidirectional. That's why I'm included at in out wire SDA and output range busy flag I need to declare, and data out this is 8-bit. So state I need to declare as 4-bit. Bit control is 4-bit, and SDA out and SDA output enable. Same thing, like assign SDA equal to when it is SDA output enable equal to 1, SDA out is initialized to SDA. Otherwise, it will be in high impedance state. Okay, so that means this is a condition that either slave is connected or not. Initially, the slave is when slave is not connected, that means it will be in open switch condition. So when the slave is connected, that means that is connected through the switch, and it is connected to the pull-up resistors, and through the VDD it is connected. That we discussed in the I2C protocol. And I need to initialize the local parameter. These states idle 0, start 1, address is 2, and one ACK is there, ACK 13, read, and no ACK is there. If not acknowledgement, no ACK is nothing but acknowledgement is not coming from the slave. Okay, and this is stop condition. First, what you need to do, you are using asynchronous active low reset. Always at the passage of clock or negate of reset begin if not of reset. If reset of underscore n equal to 0, so the default state will be idle state, and SCL I am making as 1, SDA out equal to 1, and SDA output enable equal to 1, busy equal to 0, and bit control equal to 0, and data out initialized to 0, 0. And else begin. So I'm using a case statement, case state. So when it is in idle state, SCL is already 1, and SDA out is 1, and busy equal to 0. During the start condition, what happens? So busy becomes 1. Okay, and state equal to, so start state, you go to start state. So during the start condition, first SDA will go from high to low. So SDA I'm making as 0, and state is address, and bit control is 7. Okay, the state is over. Again, address is SCL I'm making as 0. Okay, so after SDA making as 0, I need to make SCL as 0, and whatever the address is there, that is you are giving it to address of bit control, you are giving it to SDA out, and SCL equal to 1 tick binary 1, and if bit control equal to 0, state equal to ACK1, SDA out equal to 1 tick binary. During the acknowledgement, you need to make SDA out equal to 1. That is nothing but read operation. Okay, read by write bar. Read by write bar means read by write bar equal to 1 means this is a read operation. Okay, else you need to decrement. This is acknowledgement. During acknowledgement, SCL you are making as 0, output enable to 0, the release HDA for ACK, SCL equal to 1, and state equal to read operation, and bit control equal to 7, and this is the read operation. So during the read operation, SCL you made as 0, and SDA output enable equal to 0. So that means slave drives the SDA, SCL equal to 1, and whatever the data present in that SDA, that is coming into data out. This is reading operation. Okay, and if it is no acknowledgement means what, SCL equal to 0, and SDA output enable equal to 1, and SDA out equal to 1 means master will send the no acknowledgement. Okay, and next state is stop condition, SCL equal to 1 and SDA out equal to 0. So first in the stop condition, first ACL is going from 0 to 1, no? First, so ACL is making as 1, and after that SDA is going from 0 to 1. This is stop condition, and state equal to idle, and busy becomes 0. Okay, and coming to the test bench, this is the test bench for master read. One second, this is already open. Test bench, master read. This is the master test bench. So I need to declare the inputs with the reg data type, clock, reset underscore n, start, and 6 down to 0 address, and outputs with wire data type, SCL, HDA, BC, and data out. Okay, so pull up resistor model, pull up HDA. I need to instantiate. Okay, connection by name. So whatever the variables outside the bracket are nothing but design inputs and outputs, and inside the bracket are nothing but test bench input and outputs. And so first HDI data I need to initialize with 8-tick H3C and 8-bit. This is a bit control. This is 4-bit and drive slave. So I need to assign HDI equal to drive slave means whatever the slave data bit control is there, that is coming to HDI. Otherwise, it will be in high impedance state. Initial begin clock equal to not of clock. Okay, so clock equal to 0 forever. Hash by clock equal to not of clock. You are generating the clock with 100 megahertz. And first you are applying the clock and start equal to 0, address equal to, this is the slave address. Okay, after that you are desetting the reset start condition. Okay, you are running for 5 minutes. Okay, so you need to see the slave behavior. Okay, during read phase. So always at the passage of log begin. So UUT dot state equal to UUT dot read begin drive slave equal to 1, and this is the slave behavior. Okay, so this I can show you in the Vivado. So whatever you are executing, that you need to take as top module and run simulation, run behavioral simulation. So fit to page here. This is 42 address. Okay, and HDA is going from high to low, and during this state read operation is happening. Okay, read operation is happening from the slave, whatever the 3C value is there, that is happening. Read operation is getting to the master. Okay, so like this it is doing the read operation. Hope you understood. This is the coding part for I2C master. So master want to write the data into the slave, or master can read the data from the slave. This is write operation and read operation, and this is we already discussed. This is two-way communication, consists of SCL and HDA. SCL is from the master to slave. Master will generate the clock, and HDA is nothing but bidirectional. Data can be transmitted from master to slave or slave to master. Okay, so this is about the coding part of I2C. Thank you.